our next presentation, as organizations shift to hybrid and multi-cloud environments, managing identity and access management grows increasingly complex, especially with non-human identities. Gentlemen, you had me at non-human identities. Please welcome Joshua Bahirvani, an active SaaS security researcher for Microsoft, and Shaleen Dave, a senior security researcher for Microsoft.
All right, namaste from India. Thank you for having us, especially MITRE CTID and this amazing venue provided by Citi. So before we start, I had to give a disclaimer because it's something we're going to share with you regarding APTs. So all ideas or analysis shared here is publicly available, much like MITRE. And opinions shared here as researchers is to enable conversation and not to reflect to our employers or products. At the end of the day, that's what we would try to do. But with that, let's get started. So if you've gotten this card right here, right, it says change the game of the adversary. Shameless plugin for MITRE as well. But whenever I think of the game, right, I think, of course, of PC games. I am a millennial, of course. But what I actually think of is game theory. And how do you equalize this with the adversary? So when we send this CFP to John and MITRE, we were like 45 minutes of in-depth game theory conversation. John comes back, you have 15 minutes. So in all millennial gusto, we're going to speed run through this game. All right. So here are your players, right? Where's the slide? All right. Player one, that's me, Joshua. And that's player. All right. Where's this going? Yep, the joystick ain't working. So player one, that's me, Joshua. I'm a senior security researcher with Microsoft. And that's Shaleen. We're going to kind of walk you through the two stages of what we use the matrix for, right? But before setting this stage, we need to understand what a non-human identity is. And this definition is changing. There was a summit in NASDAQ recently, the Non-Human Identity Summit. Gartner is coming out with it. It's nothing but simple. We're going to just try and get you the answer. So a non-human identity, or an NHI, is basically a human or a machine-based identity, not a human-based identity, but a machine-based identity. These are your automation accounts, your service accounts if you're on-prem, right? Typically now clouds have more of them because you have so many resources that need to run autonomously in comparison to your users, right? So to give a good example for this and to make you understand how the scale of this, as of 2024, Statista kind of said that every normal enterprise, a usual enterprise, the ratio to user to non-human identity is 1:17. So each one of you has, in an average, 17 other non-user identities just in your cloud working as of now, right? This is just in your enterprise. So think of the scale. I'm not saying it's doomsday, but let's say if a breach happens, we'll tell you what happens. So there's so many types of these accounts. Agents have started being discussed. Are these NHIs? Are these not NHIs, right? So a good example would be to take an example from our own enterprise, right? Which is Azure's Entra. We use the OAuth application in Entra, which we also call the service principal tenant-wise, right? So we'll take a quick example and we'll kind of show you how adversaries kind of use it. So I'll introduce you three personas. The blue one is the compromised ghosty. The red one is your malicious ghosty. And the white one is your dormant ghosty. Very interesting topic where we discussed and when we researched, we found this. So how do APTs use this? And when we think of a game, right, we need to have a field. We need, right, somewhere to play, right? Soccer, football, whatever, right? We use the matrix right here. This is the SaaS matrix. If you go into enterprise, you open it up, SaaS matrix shows up. This is the 8-bit version of it. We couldn't get the higher graphic cards. So, all right. So on the left side, you have your beautiful adversaries who do amazing stuff as well, some things to learn from. And that's us in all gusto trying to get, defend. And our hope is to defend more towards the left side of the kill chain, while adversaries actually want to go more towards the right, if that's where the impact is. But also one thing, quick caveat, when we talk of SaaS, we also have to introduce our identity IDP matrix, and they overlap quite a bit. But we're going to use SaaS because we're going to show you how NHIs affect that. So let's take a quick example of one adversary, right? APTA. And in his back pockets, he uses the dormant ghosty and the compromised ghosty. Now, this is a real attack, and I'm going to walk you through completely what happened in the cloud. This is not touching your on-premise systems at all. So, initial access, they got a valid account. What did they get? 2016, there was some leak somewhere. They got a token. That token is alive till 2024. They logged in. They just log in nowadays. They maintain persistence. How? Because they had a token, they could refresh their token. So they have an actual valid account in your cloud systems. What they did after that is what got interesting. They started using that same compromised app was then used to then go into your key vaults or any of your vault systems and then get more, understand what that vault is sharing with as well. Your users could have it, more NHIs could have it. There was a dormant application sitting there which had an active key or a certificate available, which then it could use. It used that, created a new token for the dormant application. Now it has 2 footholds in your cloud. And what it did start doing was start escalating its privileges. So these are all valid accounts which are being used in production and all those areas. When suddenly you have proper defense evasion, here it's shorter, don't worry. They just use an alternative authentication method. What I'm saying here is they just started using a different API altogether. Usually in Entra, we have Graph. They started using ARM, which is very weird for something in the SaaS layer to start looking downwards. So this was an anomaly altogether for something that has not been active for years. What then happened is it started discovering. Now that it had these 2, it started discovering, moving laterally, and also to start doing collection. Because today, when you think of the cloud, it's a little different. They want to go for your repositories, your code bases, because that's when they get that, they can build 0 days, and that's what happens. They are able to discover easily. You're able to use alternative authentication because you have so many IDP providers, right? No one is not on just one cloud nowadays, right? They can also jump to on-prem. But this is a pure SaaS-based attack, which actually was slowly evolving more towards an infrastructure level. But let's take it a little more further. APTB. Now, APTB uses all the ghosties we know, right? So what they do is, now, you have to understand this. NHIs, like many others provided in the cloud, are multi-tenant. So you may have test tenants as well, where you're testing out, right? In this case, the OAuth application test tenant didn't have MFA. Usually, MFAs don't have NHIs don't have MFA. That's why it becomes an easy target as well. They just use pretty much password spraying, got into a test tenant. They escalated its privileges and jumped into actually the corp tenant. Now it's become a compromised app because this app is actually used in the company, but they used it in a tenant where it was dormant. Maybe it was being tested for production. Now, because of that, they also weaponized the test tenant. What they did was, in the same test tenant, they were creating multiple applications, more NHIs to be slowly moved into the corp tenant, and also found a dormant application in the test tenant, which could then be actively used there. Because of this, the only user engagement that was involved is just to consent these applications from the test tenant to the corp tenant. And that's where they had a 3-fold foothold, right? They had malicious applications, which they created, dormant applications, which was already there in the other test tenant, and a valid compromised application, which is there being used. Now that they've got this far, they start moving big, right? They were using the dormant app to do discovery. They were using the dormant app to create users to then get you in the correct IAM groups, removing them, adding them. And that's where it started going faster and faster into understanding more permission groups so that these applications, which are there, that was a lot of applications, by the way, which got consented in, could get into the correct groups so that they could finally get into what I was saying, right? Access your credentials, and more importantly, start looking at the entire scale of your cloud infrastructure through the APIs. That'll be the ARM, the Graph API, your repositories, or alternative legacy APIs like Exchange Web Services, which are very good for exfiltration today, still used by many companies and enterprises. But in all of this, the one thing that you'll have to understand and see is that we've just understood one context of it. But one of the most interesting contexts that came was, what is a dormant NHI, or in this case, a dormant OAuth application? Because when users are dormant, they're not logging in. But in the context of apps or Entra apps, it becomes different. There is API activity, even though there's no sign-in happening. They can sign into something can sign into them, and token can exist before then they're not even used. So what is dormancy? It encapsulates quite a lot of behaviors in the cloud. And this is what we could understand based on analysis using this matrix, and could understand that, hey, a non-human identity is more powerful now. Understanding this context gave us a little more usage to now actually mobilize it. That's detections. Now that we know what's a dormant app, whether it's your tenant or any other tenant or a compromised app, the dormant app, wherever there's a green box, we were able to quickly cover with detections. Let it be a dormant app suddenly activating, changing its context of usage, or just doing something completely different from its normal uses, right? It becomes more so apparent when we actually start using it for more multi-tenant attacks, because you will get a mail from someone or the other. We are a very globalized community of enterprises. You will get someone sending a guest request, you have vendors. In the multi-tenant context also, it starts helping a lot more, because just because of that understanding of NHI, the attack path becomes more easier. With that, this doesn't just equalize it, right? Game requires a little more. So I'll hand it over to Shaleen to walk you through that.
Hey everyone. So hey everyone, switching in as player 2. I hope I'll have to speed run as fast as possible. So as you all know, a disruption is like strategic measures that we can take in order to interrupt and kind of neutralize threat actors. So we have moved or evolved from more of a manual approach to kind of an automated and proactive approach at present, wherein we can tackle these threats and see to it that it causes less damage. So as Joshua was mentioning earlier, let's see how are we leveling the game field with the threat actors, and how do we kind of win the game with disruption. So how is it different from the normal disruption or kind of disruption of a user account to take? And how is NHI disruption different? So if we consider OAuth application NHI, it itself is it gets complex when we try to identify it. So identifying an OAuth application is like an OAuth application has a OAuth application ID, which is a global representation of the app, while it has a service principal ID, which is a local representation of the app in a particular tenant. So it's like if the app is a multi-tenanted app, it will have multiple service principals across different tenants where users in that tenants would have consented to the app. And consider that the ownership of the app. So ownership of the app would be like OAuth application would have a owner who actually registered the application in the host tenant, while there might be a different owner for the service principal who had consented to the service principal in a particular tenant. So let's think this particular app is a suspicious app. How are we going to disrupt? What steps do we take? So the immediate response is delete the application, because that's how the traditional approach is. But if we just delete the application, it doesn't change. So this is where we actually have to kind of compare, and let's try comparing this with a game of chess. So any move that endangers the king is the wrong move. It's the same with disruption. Any action that is taken for disruption, if it is jeopardizing the business, it's kind of a business disruption rather than an attack disruption. So this is where we kind of we need to actually think for a different approach when it comes to disruption. And we bring in game theory, a comprehensive framework wherein we have a phased approach towards disruption. So it's like we have set of actions that we perform across the attack kill chain throughout the attack tactics in a way that the impact on the users and the business is minimal. And the goal is to defeat the attacker taking the right set of disruption actions. So now we require a set of weapons. So these weapons are the disruption actions that that was mentioned. So when we consider these disruption weapons, we need to choose the right set of weapons across the kill chain when we actually put it into action. So let's look at the weapons that we can consider. So removing an application secret would be one of the weapons. deleting a service principal is like deleting the service principal from the tenant where it is active. Deleting an application itself would be removing an application from the host tenant. Removing a service principal credential would be like removing the credentials of the service principal. Disabling sign-ins from the service principal, wherein the service principals can't sign into another application. It need not be a user just signing into an application. And removing API permissions would be another one. Revoking access tokens would thwart the activity of the app itself. Disabling sign-ins to the service principals would be another one, wherein users cannot sign into the service principal. Revoking app role assignment from the app would be another one. So let's see how are we using these weapons for APT 1 and 2. So we kind of revoke the API access at the collection phase in a way that it doesn't allow the threat actor to use APIs like Graph API, ARM API, and EWS API. We revoke sign-ins to the service principal, which doesn't allow users to sign in and consent to the service principal. We revoke app role assignment permissions in a way that it doesn't perform discovery activities. We can remove high privileges to the application, which would actually allow the application to access stored credentials, maybe a key vault or something, and also revoking the access token in a way that no token theft happens. We can also leverage for defense evasion service principals. So threat actors can leverage the service principal, and we can actually disable sign-ins to the service principal in a way that it actually doesn't evade detection. From a privilege escalation, we can revoke credentials and secrets in a way that none of the privileges are being escalated. And this is where we actually have the persistence phase, where if we are confident enough, we can actually disable the service principal and not allow it to be active at all. As this scenario had a dormant application at the beginning, if we are able to revoke the token at the initial phase of the kill chain, we could have actually thought this attack from happening at all. Speed running again. So as part of the second APT or the APTB, it's almost similar to the other moves that we have taken or the weapons that we have used. But how is this different from the other APTs? This particular threat actor used a dormant application, a compromised application, and a malicious application. So when it comes to a dormant application, revoking token would thwart or stop that particular dormant application from being active. Having the service principal disabled would stop the compromised app being active, and deleting the application would have stopped the malicious application that was created from getting active. So this is how we could have actually stopped the whole attack from happening. So it's time to level up. So considering the challenges that we are facing. So if we consider a compromised user in a tenant, in the recent campaigns that we have seen, every user that is compromised is seen to have at least 5 NHI OAuth application related NHIs as part of the tenant, which is kind of getting active. We have seen OAuth applications leveraged to access emails, send bulk phishing emails, also accessing and listing out people, etc., leveraging Graph API. We as part of defenders, we should actually use the disruption to shift this to the early phases by identifying the NHI attack paths that we have. And as apps can be multi-tenant, having a clustering or doing a clustering across multiple tenants can actually help us generate intel on NHIs, which can be leveraged to disrupt at an early phase in a new tenant. So now it's game on. So cybersecurity has always been a team sport. We are part of a multiplayer game. As part of community, we are actually fighting against the threat actors, and be sure that we use the right set of weapons to fight against the threat actors. And next time you see a suspicious activity, there is high chance that there is an NHI that is actually under the radar. So be sure to use the right set of weapons and win the game. Yeah, thank you.